Hello viewers, welcome to my YouTube channel. Welcome to Simple Science. In this video, I'm going to show you how to solve for Waec 2014 chemistry practical question on titration and question 1. It says A is a solution of hydrochloric acid. B is a solution containing 2.45 grams of anhydrous sodium triisocarbonate 4 in 250 cm³ of solution. Put A into the burette and titrate it against 20 cm³ or 25 cm³ portion of B using methyl orange as indicator. Repeat the exercise to obtain consistent titers. Tabulate your burette readings and calculate the average volume of A used. The equation for the reaction involved in the titration is sodium triisocarbonate 4 plus hydrochloric acid yields sodium chloride plus water plus carbon 4 oxide. Part B says, from your results and the information provided, calculate the concentration of B in mole per dm³. Calculate the concentration of A in mole per dm³. And then the third one is to calculate the concentration of A in grams per dm³. Concentration of A in grams per dm³. And then the fourth part says that the volume of the gas involved in the reaction at STP. And we have all of this given. These are the masses of the atoms involved in the reaction. And then we have that molar volume is equal to 22.4 dm³. That's at STP. So these are the information we have. And then in this video, the first assumption is that the practical has been done, and then the values of the data values have been obtained. So this is how to go about it, how to draw the table. So we are using these values, and then we'll use these values to solving for the answers to this question to them. So but for this calculation, the practical has been done already and the values have been obtained, and you have them here. And so we are going to use the information given to us and these values obtained to finding the solution to this. So the first thing to do is to write solution, and after solution to write the indicator used. The question has given us the type of indicator we should use. The question says using methyl orange as indicator. So methyl orange is our indicator, and then the next thing we take note of is the volume of the base. The question says put A into the burette and titrate it against 20 cm³ or 25 cm³. So for this practical, we are using 25 cm³ as the volume of base, and then this is the table of values obtained after the practical. So this is how the table of values should look like for titration. We have the burette reading. This is initial burette reading. This is final burette reading, and then you have the volume of the acid used, and then you have your rough titer, the first titration, the second titration, and the third titration, and then we have this. So I will explain some things on this table, and then we get along. The volume of acid used is obtained by subtracting the initial burette reading from the final burette reading. And so volume of acid used is equal to final burette reading minus initial burette reading. The same thing to here, final burette reading minus initial burette reading will give you the volume of the acid used. So that's how the volume of the acid used were obtained, the volumes. And so we are not to use the volume of acid used in the rough titration to calculate for our average titer value. We are not to use it. But then we use the first, second, and third. If you look at them, you will notice that they are within the range of 1.0. 21.50 and 21.40. They have a difference of plus 0.1. So the difference in your average, or the difference in your titer values for the first, second, and third, especially the ones you will use to compute your average titer value or the average volume of acid used. Average titer value means average volume of acid used, and so the one you will use to do the ones you will use to compute that should be within the range of plus or minus 0.1 for accuracy. So here we have the volume of acid used, and we have the table, we have mentioned the indicator used and the volume of base we are working with, so we can get along. The next thing is to calculate for the average titer value, and then we say average volume of acid, used is equal to the first titration plus the second titration plus the third titration values for the volume of acid used. So we take for the first titration we have 21.4 plus the second we have 21.5 plus the third we have 21.4, and then we divide them by 3 because they are 1, 2, 3. We did the titration 3 times. So when we do this, if we sum them up, we're going to have 64.3 divided by 3. If we do this division, we're going to have 21.43 cm cubed. This becomes the volume of our acid, V subscript A. So this is the volume of acid. So in order for us not to forget it, I will include it here. Let me include it here. So let's say VA is equal to 21.43 cm cube. Alright, so we have gotten this, and then we'll go to the next aspect of solving this question. These values, the volume of the base, we are going to use it as we get along. The next thing we are going to do is to write the equation of reaction and then balance it if it is not balanced. In some cases, the equation may be balanced. In some cases, the equation may not be balanced. But then, like in this case, we can see that it is balanced already. So we have the equation of reaction. Let me roll this. We have the equation of reaction, and then we have Na2CO3 plus 2HCl. Let's say it was not balanced, and then we'll have NaCl plus H2O plus CO2. So let's say we have this to be the equation of reaction, and we have it. This arrow sign separates the reactant part from the product part. Separate the reactants from the product. So this is like a bridge, separating the left-hand side from the right-hand side. So on the reacting side, we have that 2 atoms of sodium is involved in the reaction. 2 atoms of sodium. So, and we look at the product side, there is only 1 atom of sodium here. So we will make it 2. Now we cannot put 2 here. No. So you put 2 here in front of sodium chloride. When we put 2 here, sodium is now 2 here, and it is 2 here. That's fine. But we also look at chlorine. Chlorine becomes 2 on the product side. And then we look at chlorine on the reacting side. It is 1. So we put 2 in front of HCl. That's hydrochloric acid. So chlorine is now 2. Hydrogen here is now 2 because of these 2 we put. And then we look at the product side. Hydrogen is 2, that's correct. And then now we are done with hydrogen, we are done with chlorine, we are done with sodium. We look at carbon. Carbon is 1 and oxygen is 3. So we look here, carbon is 1 and oxygen is 2 plus 1, 3. So the equation is balanced like this. So what this means is that you have 1 mole of sodium triazocarbonate 4 reacting with 2 moles of hydrochloric acid to give you 2 moles of sodium chloride plus 1 mole of water plus 1 mole of carbon 4 oxide. So that's the interpretation. And from this, we look at the next question. So we go to B. So question B has it that from your results and the information provided, calculate the concentration of B in mole per dm cube. So we are looking at concentration of B in mole per dm cube. So for this, there are 2 formulas that can be used to finding the concentration of B in mole per dm cube. The first one you can use, this is in mole per dm cube, and so you can use concentration in mole per dm cube is equal to concentration in grams per dm cube over molar mass. So we can use this formula to find the concentration of a compound in solution in mole per dm cube, or we can use the mole ratio of the acid and base. So we can use number of moles of acid all over number of moles of the base is equal to concentration of acid times volume of acid all over concentration of base times volume of base. So whenever you see that you have to calculate for the concentration of B or any compound in mole per dm cube in titration, these two formulas should first come into your mind, and then you look at the information you have, which of them will be best for the calculation. So in this case, we can find the concentration of B in grams per dm cube, because if we want to find the concentration in mole per dm cube, we need to know the concentration of B in grams per dm cube. So we can look for that from the information given to us, and then we can also look for the molar mass of B, because we know the atoms, the elements, and the number of atoms that make up that compound. So, but we will not use this formula here. We are going to use this first formula. The reason we can't use this formula here is that we do not know the concentration of the acid in mole per dm cube. Although we have known the number of moles for the acid to be 2 and the number of moles for the base to be 1, we have not known the concentration of the acid in mole per dm cube, and then we have known the volume of the acid and the volume of the base. So because we don't know the concentration of the acid in mole per dm cube, we can't use this formula. So we are going to use the first formula that we have on the board. So we have concentration in mole per dm cube is equal to concentration in grams per dm cube over the molar mass. So we have to look for two things now. We have to look for the concentration of B in grams per dm cube, and then we have to look for the molar mass of B, and then we substitute them in the equation to finding our solution. So let's look for the concentration of B in grams per dm cube. So this is how it goes. So we have that the question here says B is a solution containing 2.45 grams of anhydrous sodium trihydrocarbonate 4 in 250 cm cube of solution. What this means is that you have 250, this is 250 cm cube, that's the volume of solution, and inside you have B, and let's say this is your B, and the mass of B inside this 250 is 2.45 grams. So that's what this statement means. This is your B. So this statement means that a B is a solution containing 2.45 grams of anhydrous sodium trihydrocarbonate 4 in 250 cm cube of solution. So this is 250 cm cube of solution, and you have 2.45 grams of B of sodium trihydrocarbonate 4. Now, so we can say that 250 cm cube of B contains 2.45 grams of sodium trihydrocarbonate 4. Contains 2.45 grams. Now, but we want to work with 1000 cm cube, because 1000 cm cube is equal to 1 dm cube, and 1 dm cube is the standard of reference. Remember that at STP, the volume of a gas is 22.4 dm cube. So 1000 cm cube is equal to 1 dm cube, and that is a kind of standard in calculations like this. So we don't want to work with this cm cube. So we want to convert from cm cube to dm cube. So if 2.45 grams is inside 250 cm cube, then it's 1000 cm cube will contain, remember that 1000 cm cube is 1 dm cube, that's why we are using 1000. We contain, see the formula now, 1000, we contain 1000 times 24.5 all over 250. We contain will contain 1000 times 2.45 all over 250. So this will give us, if we do this, sorry, this should be 2.45 from the question. And so if we do this, we are going to have that this will be 9.8 grams per dm cube. So the concentration of B in grams per dm cube will be 9.8 grams per dm cube. It means that in 1 dm cube we'll have 9.8 grams. What that means is that this is 250 cm cube. If you bring another 250 cm cube, you will have 500 cm cube. So if you bring 250 cm cube times 4 of this will give you 1000 cm cube, which is equal to 1 dm cube. And then in 4 of these, you will also have this number times 4, and 2.48 times 4 will give us 9.8 grams. So there will be 9.8 grams inside 1000 cm cube. That's what this thing means, and then that's why it is the concentration in grams per dm cube. Now, also know that concentration in grams per dm cube is also known as mass concentration, because this is mass. Grams is in mass. Sorry, mass is measured in grams, and then the dm cube is the unit for the volume. So this is mass concentration, and then the concentration in mole per dm cube is the molar concentration. So the next thing we look for is the molar mass of B. So we have the molar mass of B. Now, what is our B? Our B, which is the base, is Na2CO3. So we want to look for the molar mass of sodium triocarbonate 4. That's our B. And how do we do it? This is how to go about it. B is equal to, let's say, molar mass of B is equal to, you have two atoms of sodium plus 1 atom of carbon plus 3 atoms of oxygen plus 3 atoms of oxygen. And we know that the mass number of sodium is 23, the mass number of carbon is 12, the mass number of oxygen is 16. So we are going to put their mass numbers. So we have 2 times 23 plus 12 plus 3 times 48. And this will give us 46 plus 12 plus 3 times 48 will give us 3 times 8 is 24, 4 carry 2, and then 3 times 4 is 12 plus 2, 14. So, this will be 3 times 16, because the mass of oxygen is 16, 3 times 16. So 3 times 16 will give us 48, that was another side. And then when we sum everything, it will get 106 grams per mole. Please take note, the unit for mass concentration is gram per dm cube. The unit for molar mass is gram per mole. So we can say, therefore, concentration of B in mole per dm cube is equal to, from the formula we have it that it will be equal to the concentration in grams per dm cube divided by the molar mass. So what we have, the concentration in grams per dm cube is 9.8 divided by the molar mass now is 106. So when we do that, this concentration of B in mole per dm cube is our C subscript B, the concentration of B in mole per dm cube. And when we do that, we are going to get 0.0925 mole per dm cube. So that's the concentration of B. And then let me write it here so that we will not forget it. 925 mole per dm cube. So we have these two. The next thing we look for is the concentration of A in mole per dm cube. We are still solving question B, and this is I, and we are looking for the concentration of A. Concentration of A in mole per dm cube. That's our Ca. So in this case now, we can use the mole ratio for the acid and base. So we can use this formula, Na all over Nb is equal to, remember that number of moles is equal to concentration times volume. So the number of moles of the acid will be equal to the concentration of the acid times the volume of the acid all over the concentration of the base times the volume of the base. So we have Na over Nb is equal to CaVa all over CbVb. We need to check if we have all the parameters required to find in the formula. From the equation of reaction, look at it here also, this equation is balanced as well. You have that 2 moles of the acid is reacting with 1 mole of the base. So we have that, let me write them here. So we have that our Na is equal to 2, our Nb is equal to 1, and then we also have that the volume of our acid the volume of acid Va was obtained from the titration, that's the average titer value. So Va is equal to 21.43 cm cube, and Vb is the volume of base that we are using, that's 25 cm cube. And then we also have our Cb, that's the concentration of the base, concentration of B in mole per dm, that's Cb. So we have Cb to be equal to 0.0925, and then we are looking for Ca. So we have everything needed to find Ca. So we make Ca the subject of the formula, and then we cross multiply. On cross multiplying, we have CbVb times Na is equal to CaVa times Nb. So to make Ca the subject of the formula, we divide both sides by VaNb. So CbVbNa all over VaNb is equal to CaVaNb all over VaNb. And why we are doing that is so that Va can cancel Va, Nb can cancel Nb, and then Ca will be equal to CbVbNa all over VaNb. So if we are substituting, our Cb is 0.0925 mole per dm cube times our Vb is 25 cm cube times our Na is 2 all over, that's the number of moles of acid is 2 all over, our Va is 21.43 times our Nb is 1. So if we substitute correctly, we are going to get that our Ca will be equal to 0.108 mole per dm cube. If you look here, you will notice that the unit of Cb is in mole per dm cube, and then the unit of Va is in cm cube, and the unit for the Na and Nb, they don't have any unit because they are expressions in ratio, so they don't have any unit. And so you'll find that the unit of Va is also in cm cube. So there's no need to convert this one from cm cube to dm cube to match the unit for the concentration in mole per dm cube, because cm cube of the acid, or the volume of acid, we cancel cm cube of the volume of the base, and then they will cancel out, and our unit will be in mole per dm cube. So we have this here, and then that is the answer for our Ca. So let me say Ca is equal to 0.108 mole per dm cube. Now we go to the next question, the concentration of A in grams per dm cube. Concentration of A in grams. So we have the third part. Third part is concentration of A in grams per dm cube. Here we have to use the formula that concentration in mole per dm cube is equal to concentration in grams per dm cube all over molar mass. And from this formula, we have that the concentration of A in grams per dm cube, that means concentration of A in grams per dm cube will be equal to concentration in moles per dm cube times molar mass times the molar mass. And so we have known the concentration of A in mole per dm cube, that's our Ca, but we need to find the molar mass of A, and A is the acid, hydrochloric acid. So we say molar mass of A, that's HCl. Here we have one atom is equal to one atom of hydrogen plus one atom of chlorine. So we substitute their mass numbers. Hydrogen has a mass number of 1, plus chlorine has a mass number of 35.5, and then 1 plus 35.5 will give us 36.5 grams per mole. Please always put the units of whatever you're calculating for. So we have it as 36 grams per mole. We'll say therefore the concentration of A in grams per dm cube is equal to, we will now use this formula, concentration in grams per dm cube is equal to concentration in mole per dm cube times molar mass. Concentration in mole per dm cube is 0. We have gotten it already to 0.108 times 36.5. So when we do this times 36.5, we'll have this to give us 3.942 grams per dm cube. So this will be the answer for the concentration of A in grams per dm cube. The next thing we are going to look at is the volume of the gas involved in the reaction at STP. The volume of gas involved in the reaction, let me write reaction like this, at STP. Okay, so for us to be able to do this, we know that only one type of gas was involved in the reaction, and that gas is carbon dioxide gas. This is sodium chloride salt, this is water, and this is carbon dioxide gas. So carbon dioxide is a gas that was involved in the reaction. And so we need to calculate the volume of that gas. Let me draw our attention to the equation of reaction. The equation of reaction has it that Na2CO3 plus 2HCl gives us Na2NaCl plus H2O plus CO2. Now if we look at the mole ratio, we know that 1 mole, let me write the mole ratio, the mole ratio. We have 1 mole of sodium carbonate 4 reacting with 2 moles of hydrochloric acid, giving us 2 moles of sodium chloride plus 1 mole of water plus 1 mole of CO2 gas. So when we look at the mole ratio, we have it that 1 mole of sodium carbonate 4 involved in this reaction produced 1 mole of CO2 gas. So we say 1 mole of this produce 1 mole of CO2. And so we have been told that in this reaction that the molar concentration of the base of B is 0.0925. That means 0.0925 moles of Na2CO3 we still produce the same, because the mole ratio is 1:1. So 0.0925 we also produce 0.0925 times 1/1, which will give us 0.0925 moles of CO2. So it means that 0.0925 moles of sodium carbonate 4 will also produce the same amount because their mole ratios are the same, 1:1. So it will produce this. So we have that 0.0925 moles of CO2 is produced. Now, we also know that number of moles, don't forget that this is the moles in 1000 cm cube. That's why it is moles per dm cube. So this is the number of moles in 1000 cm cube. So hold that information and then I'll show you where we're going to apply it. So the next thing is that we know that but number of moles is equal to volume over molar volume. That's volume, let me write it here, volume over molar volume, so number of moles. So which is equal to, volume is V, and then molar volume is V subscript M, molar volume. So M is equal to V over Vm. We have it with this, and we are looking for the volume. So volume will be equal to, we cross multiply, volume will be equal to number of moles times Vm, will be equal to number of moles times V subscript M. So the volume of carbon 4 oxide, the volume of carbon 4 oxide liberated will be equal to the number of moles of carbon 4 oxide, which is 0.0925 moles times 22.4. Remember that why we use 22.4 is that at STP, a gas occupies 22.4 dm cube. And that's why the question said, calculate the volume of the gas involved in the reaction at STP. So the molar volume at STP, molar volume is 22.4 dm cube. So the volume of CO2 will be equal to the number of moles times molar volume, which is 22.4. And if we do this sum, we're going to have 2.072 dm cube. Remember that we are considering the volume is volume, so we are going to have this dm cube. But the question says that we should calculate the volume of the gas involved in the reaction. And in the reaction, remember that dm cube means 1000 cm cube. In the reaction, we use 25 cm cube of the base. But this is telling us that in 1000 cm cube of the base, we will have this volume of carbon 4 oxide liberated. That means 1000 cm cube of this base will liberate this volume of carbon 4 oxide. That's what this thing means. Remember that this number of moles we use here, this number of moles we use to get the number of moles for our CO2 was the number of moles in 1000 dm cube. So in 1000 cm cube, you have 0.0925 moles. So you have that, and then that number of moles will liberate 2.072 volume of CO2, because that's what we use to arrive at this answer. So we are going to say that in 25 cm cube, the volume of gas evolved will be 2.072 times 25 over 1000. So this will give us, when we do this, we are going to have 0.0518 dm cube. Remember that this our unit is in dm cube, this is in cm cube, this is in cm cube, and then we're going to have it to be this in the reaction, dm cube. If you don't want to do it like this, you can also convert it to cm cube, or if you multiply this by 1000, 1, 2, 3, you have 51.8 cm cube, because 1 dm cube is equal to 1000 cm cube. So if you multiply it by 1000, you are converting it from dm cube to cm cube, and we arrive at this. So this is the answer. Don't forget that the question says that we should look for the volume of the gas evolved in the reaction, and that's why we have to check for the volume that we evolved where we used 25 cm cube, because that was the volume of the base that we used. So this is how to go about the questions for this. So you can go over it, and then don't forget to like the video and subscribe to the channel, and also share to your friends, and then try your hands on the exercise that you see at the end of the video.